Very good evening to everyone. Welcome back to NEET World. Now in the last session we have completed different chapters, right? Today we are going to start analytical chemistry. In analytical chemistry we will learn how to identify if any ion is present in a given solution, what type of ion is present, what type of cation is present, we will find it. See, in analytical chemistry, first, what is analytical chemistry? Analytical chemistry, it deals with the identification of substances. Analytical chemistry deals with the identification of substances and determining the composition, what type of composition is present in that. Qualitative analysis, it answers which ion is present. Means, for example, any salt is given to you. If we are asking what type of cation is present in that, how to check? With the help of analytical chemistry, that qualitative analysis means what type of ions are present, we can check. Now, here in this chapter, we mainly focus on sodium hydroxide and ammonium hydroxide. By using those two as the reagents, how to check the presence of different cations, we will learn in this chapter. See first, how do those hydroxides will form? Before that, we are using two reagents, right? One is sodium hydroxide and another one is ammonium hydroxide. We know very well that sodium hydroxide, it is a base because OH minus ion is there, and this sodium hydroxide, it will dissolve in water, right? And it will undergo complete dissociation, means it is a strong base. Sodium hydroxide is a strong base, whereas ammonium hydroxide, it is a weak base because complete dissociation of ions will not take place. It will undergo partial dissociation of ions. Let us see, for example, NaOH if we are taking, why we are saying it as strong bases, we have learned already in acids bases chapter. NaOH, in the presence of water, complete dissociation of ions takes place as Na plus and OH minus, whereas NH4OH, in the presence of water, partial dissociation of ions, NH4 plus OH minus. Okay, here partial dissociation takes place, whereas here complete dissociation of ions takes place. That's why this is strong base, whereas this one is weak base. By using these two as a reagents, how we are going to check whether the given sample of salt contains which type of cation? Let's see. Entire chapter reaction pattern is like this. We will take any metal salt like copper sulfate, magnesium chloride, ferric chloride, different salts we will take. We will add with the alkali. What do you mean by alkali? We have already discussed that alkali means it is a base, right? Alkali is a base which dissolves in the water. See, sodium hydroxide is there. If we are adding sodium hydroxide in the water, it will dissolve after stirring for some time. Sodium hydroxide will dissolve in the water. So, if any base soluble or dissolves in the water, then we will call it as alkali. Now here we are taking sodium hydroxide as our alkali. Metal salt reacts with alkali and we will get insoluble metal hydroxide and also soluble salt. Okay. Now see the example, metal salt, I have given here copper sulfate. Copper sulfate, if you see, this is our metal salt. What is the color of copper sulfate? Its color is blue color. Fine. So, it is reacting with alkali, sodium hydroxide. This is soluble in water, that is why we are calling it as alkali. Now, after reaction with sodium hydroxide, we will get copper hydroxide, CuOH taken twice, as precipitate. As precipitate. Precipitate is nothing but a solid, insoluble solid or soluble solid. It is a solid which is formed during the reaction. After that reaction, whatever the solid we are getting, that solid we will call it as precipitate, and the reactions generally we will call it as precipitation reactions. So, after the formation of solid, it will settle down, right? So that's why normally precipitates will represent with down arrow. Now next, along with copper hydroxide we are getting Na2SO4 salt. Okay. Now see, we will see different examples how hydroxide ions, how sodium hydroxide and NH4 hydroxide we are using in order to check different metal ions. What is the procedure for that? First we will take sodium hydroxide. Sodium hydroxide is added dropwise to the given salt solution. We will take any salt solution, copper sulphate just now we have seen, or any magnesium chloride or ferric chloride, any salt solution we will take, and we will add NaOH drop by drop. NaOH solution we have to add for that salt solution. Then what we have to check? We have to check whether any precipitate is formed or not, any solid is formed or not in that reaction. A precipitate may be formed due to the formation of metal hydroxide. Okay. When we are adding NaOH solution to the salt solution whatever we have prepared, then we can observe any precipitate is formed or not. This is our first observation. Next, after formation of precipitate, little bit extra amount of NaOH solution we have to add, means excess amount of NaOH solution is added to check whether the precipitate dissolves in NaOH or not. Whatever the precipitate we are getting here, whether it is dissolving or not, we are going to check it. So what we are finding? First we are checking whether the precipitate is formed or not, and second thing we are checking by adding excess amount of the reagent NaOH, we are checking whether the formed precipitate is dissolving in the NaOH or not. If you are taking NH4OH, okay, if you are taking NH4OH, NH4OH is a weak alkali, okay, it is dissolved in water, but it is very weak base. So here I have mentioned weak alkali, and it plays an important role in the qualitative analysis as a reagent. So what is the procedure? Same procedure by using NH4 ammonium hydroxide also we have to follow same procedure. First we have to add NH4OH dropwise to the given salt solution in order to check which ion, which cation is present, and then observe whether the precipitate is formed or not. Then add excess amount of NH4OH solution, ammonium hydroxide in excess we are adding in order to check the solubility of the precipitate formed. Along with this, whatever the precipitate we are getting after addition of NaOH or NH4OH, sodium hydroxide and ammonium hydroxide, along with checking precipitate is formed or not, we are checking, right? After checking that, we have to concentrate on color also. Which color PPT we are getting, which color precipitate we are getting, we have to concentrate. Now see, we will see some examples here. Important cations I have mentioned here. First cation Cu plus 2 means copper by losing 2 electrons Cu plus 2 is formed. Now this Cu plus 2, if you are adding copper, let us take CuSO4 salt. Okay, what is the charge of copper here? Plus 2, understood, and SO4 minus 2. Now in the presence of this salt solution, if you are adding NaOH solution to this, so what will happen? Let us see the reaction. Copper sulphate, we are taking NaOH, fine, we are taking 2 NaOH, then what will happen? Copper reacts with opposite charges will react, right? Here copper plus 2, here SO4 minus 2 and Na plus OH minus. So what will happen? It results in the formation of here copper and here OH, will get CuOH taken twice. Along with that, what will get here? Sodium and here SO4 will get Na2SO4. Okay, this is our PPT, this is our precipitate. So copper hydroxide CuOH taken twice precipitate we are getting, and what color? Light blue color precipitate we are getting. Now and this for this, after formation of precipitate, if you are adding excess amount of NaOH, it is insoluble. Whatever the PPT precipitate we are getting, that precipitate copper hydroxide is insoluble in the presence of excess sodium hydroxide solution. Now see the next one, Fe plus 2 ion. Fe plus 2, let us take FeCl2 as an example. Now this FeCl2, if you are adding to this solution, if you are adding, let us take FeCl2 plus NaOH we are taking, okay, 2 NaOH in order to write balanced equation. FeCl2 we are making it to react with NaOH reagent, we have add solution, then what we will get, FeOH taken twice. This Fe reacts with OH minus, means forms a bond with OH minus. Now what else we will get? We will get NaCl. How many? 2 molecules. Now see, FeCl2 on reacting with 2 sodium hydroxide molecules, we are getting FeOH taken twice and NaCl. Now here FeOH taken twice is there, this is our precipitate. Now what is the color of that precipitate? Dirty green color, means very thick green color precipitate of ferrous. Fe plus 2 is there, ferrous we will call iron hydroxide or ferrous hydroxide we are getting. And that after formation of this precipitate also, what we will do, our common procedure is we have to add some excess amount of NaOH in order to check whether the formed precipitate is soluble in the excess amount of base, alkali or not, right. So we are adding NaOH excess, we are adding, and what will happen, it is insoluble. Whatever the excess amount we are adding, after that formed precipitate ferrous hydroxide is insoluble in the NaOH, that is our Fe plus 2. Now next Fe plus 3, if you are taking Fe plus 3 ion, let us take FeCl3, okay, plus 3. This Fe plus 3 on reacting with NaOH, whatever we are adding, reaction takes place. What will happen, ma? FeCl3 plus NaOH. How many we need? We need 3. Now by the reaction between these two, we will get FeOH taken 3 plus what else we are getting? NaCl, right. So this is our precipitate, Fe ferric hydroxide is our precipitate, and what is the color of that? Reddish brown color PPT will be formed. It means that ferric hydroxide is formed. Ferric hydroxide with reddish brown color PPT is formed, and now we have to check for the solubility of the precipitate formed. So what we will do, we will add some extra amount of NaOH solution, then it is also insoluble. It means that whatever the cation is there, that cation is Fe plus 3 in the given salt. Let us check Zn plus 2, zinc with plus 2 charge, zinc with plus 2 charge, let us take zinc sulfate plus what will happen, we are adding NaOH. Now gives rise to zinc reacts with OH, forms bond with OH, will get ZnOH taken twice, okay. Along with that what else we will get? Plus Na, sodium and sulfate, we will get sodium sulfate, Na2SO4, okay. So this zinc hydroxide is there, this is our precipitate here, and that is the salt, Na2SO4 is the salt. Now this metallic hydroxide, zinc hydroxide is there, we have to check for the solubility. So what we will do, we will add excess amount of NaOH, then this zinc hydroxide will dissolve in the presence of excess amount of NaOH, right. This is all about different ions, different cations in the presence of how they will react with the NaOH. Let us see more examples. Now see here, aluminium plus 3, aluminium plus 3, similarly AlCl3 will take. Now on reacting with NaOH, what will happen? It results in the formation of aluminium hydroxide, Al. Here Al is there, which is having charge plus 3, and here in this we are having OH minus, here plus and there minus, means cation, here anion, they will form bonds with each other. Al, OH taken thrice. Okay. Along with this, what we will get? We will get Na here, Cl is here. So, we will get NaCl. How many? 3 molecules. Fine. So, here what is our precipitate? Aluminium hydroxide. Aluminium hydroxide is our precipitate. Now, what we have to do? Yes, fine, we got the precipitate with white color. There is no other colors. What color precipitate we are getting? We are getting white color aluminium hydroxide. Now, what we have to do? We have to check for its solubility. So, what we will do? We will add extra amount of NaOH solution. So, we will see that this aluminium hydroxide, it will be soluble in the presence of excess amount of sodium hydroxide, right. Now, check for Pb plus 2, lead plus 2. Next, Pb plus 2. Similarly, Pb, lead chloride or any salt solution we will take. We will add excess amount, we will add NaOH solution. So, in the presence of NaOH, we will get lead hydroxide, which is white in color. This is our precipitate. Now, what we will do next? We will add excess amount of sodium hydroxide. It will be dissolved. That means the given cation is Pb plus 2. Then calcium plus 2. Very important, calcium hydroxide. Will take any salt, calcium sulfate or calcium chloride, any salt we will take, solution we will prepare. To that solution, we will add solution of NaOH. Then what will happen? That NaOH will react with the calcium salt solution. Then we will get calcium hydroxide, which is white precipitate. Done. Now, what will happen? To this precipitate, we will add excess amount of NaOH. You will see slightly soluble. It is slightly soluble. Calcium hydroxide is slightly soluble in the presence of excess amount of NaOH. Now, next one, NH4 plus. I will explain this in detail. Now, if you observe, we have seen aluminium hydroxide, we have seen zinc hydroxide, we have seen lead hydroxide, we have seen. What we got? These all, they are dissolved, soluble in the excess amount of sodium hydroxide. See here, because these hydroxides are amphoteric in nature, right. Aluminium hydroxide, zinc hydroxide and lead hydroxide, these are all amphoteric in nature. Amphoteric ante enti ma? Amphoteric means they behave as bases and acids. In the presence of base, if they are reacting, they will act as acids. In the presence of acid, they can behave as bases, that is amphoteric in nature. That is why they react with excess amount of NaOH to form soluble complexes, okay. And therefore, as they are soluble, whatever the precipitate is formed, it will disappear. Now, NaOH completed. By using NaOH as a reagent, we have checked for different cations how to identify. Now, let us see ammonium hydroxide. NH4OH is nothing but how to call its name is ammonium hydroxide. NH4 we will call it as ammonium, OH is there, hydroxide, ammonium hydroxide. Now, let us see again for copper plus 2. Copper plus 2, any solution we will take, it will make it to react with, we will add NH4OH solution. Then what will happen? It will form a light blue color precipitate. Then we will add extra amount of ammonium hydroxide. So, what will happen? It will dissolve with deep blue color solution. Now, see the next one, Fe plus 2. See next one, Fe plus 2, again we will get green color, and when we are adding excess amount of solution ammonium hydroxide, it is insoluble in that. Then see the next Fe plus 3, if you are adding NH4OH ammonium hydroxide solution, we will get reddish brown color precipitate. Then if you are adding excess, whatever the complex formed, it is insoluble. Next, zinc plus 2, Zn plus 2, we will get white precipitate by the reaction with ammonium hydroxide. Then if you are adding excess amount, what will happen ma? It will be dissolved. Next, aluminium salt solution if you are taking and we are adding ammonium hydroxide solution, you will get white precipitate which is insoluble in the presence of excess amount of ammonium hydroxide. Now, plus 2, we have already seen. What will happen? NH4 OH dropwise we have to add. Light blue color copper hydroxide precipitate is formed, and if you are adding excess amount, it will be dissolved. Copper plus 2 is very important cation, keep it in mind. See, here I have given some important reactions. Once you see that, so see here, copper plus 2 and OH minus. What will happen? Copper plus 2 in the presence of OH minus ions, it will be formed CuOH taken twice. Means here if we are taking ammonium hydroxide or sodium hydroxide, copper plus 2 it will react with the opposite charge, minus charge hydroxide. So we will get copper hydroxide. As it is a precipitate, we will represent with down arrow. Similarly, see Fe plus 3 reacting with OH minus. Fe plus 3 plus 3 OH minus results in the formation of FeOH taken thrice, and it is a precipitate, we will represent with down arrow. Similarly, see Zn plus 2 reacting with 2 OH minus ions, we will get zinc hydroxide. This is very small chapter and easy chapter also. Let us see ammonium, test for ammonium ion. How to check whether the given salt contains ammonium ion or not? See, we have to add NaOH solution to the given ammonium containing salt solution. Then what we have to do? We have to heat it little bit. First what we are taking? We are taking the salt solution which contains ammonium ion, and to that solution we are adding sodium hydroxide, which is our reagent. So what will happen after addition of that? We have to heat it little bit. Then ammonia gas is evolved by the reaction between sodium hydroxide and ammonium containing salt solution. Between those, what will happen? Ammonia gas is evolved. Ammonia formula is NH3. Its formula is NH3. So NH3 ammonia gas, it will release a pungent smell. So what will happen? It will release a smell. Along with that, as it is basic in nature, it turns red color litmus paper into blue color litmus paper. So by this color change and this smell, based on these two observations, we can say that yes, the given salt contains NH4 plus cation. Now the ionic equation, once you see NH4 plus, we are taking the salt solution which contains ammonium cation, and NaOH we are taking. Then reaction between these two, we are getting NH3 as a gas. As it is gas, gas will move in upward direction, right? So we will represent with upward arrow. Along with that, we are getting water. This is how to identify whether the given salt contains ammonium cation or not. Fine. This is what we have discussed today. First, what we have to do in order to check whether the given salt contains which type of cation. First, we have to make the solution of that given salt. Then we have to add either NaOH as a reagent as NH4. Any one reagent we have to add NH4OH ammonium hydroxide or sodium hydroxide. Then what will happen? Some PPT will be formed. We have to check whether PPT is formed or not, and also we have to check which colored PPT is formed. That is our second observation. Then we have to add excess amount. If you are using sodium hydroxide solution, you have to add little excess after the formation of PPT. Then check whether the formed PPT is dissolving in the presence of excess amount of reagent or not. Then check. Based on the observation here and here, we can find what type of cation is there in the given salt. This is all about analytical chemistry. This is all for today. Thank you.